Okay, so let's continue on with this past paper. So question 10 is a geometric progression has first term a and common ratio r, where r is greater than 0. The second term of this progression is 8. The sum of the third and fourth terms is 160. All right, so let's just write this information down. So second term means that you have first term a multiplied by the ratio once. It's a times r. And this is equal to 8. The third term is ar squared because you multiplied it by the ratio twice by the first number, plus ar cubed to represent the fourth number is equal to 160. So this equation they've given us is based on these two pieces of information. Therefore, because there's only r in this equation, we have to assume that a is somehow, replaced. So why don't we replace the a in ar squared plus ar cubed with a value of r. So let's rewrite a in terms of r. So a is equal to 8 over r. And now let's substitute that into this equation. Using that, we can get 8 over r times r squared plus 8 over r times r cubed is equal to 160. So we get the 8 over r, the r cancels out with one of the r's to make r. Here, r cancels out with one of the r's to make r squared. So we get 8r plus 8r squared is equal to 160. Everything is divisible by 8, so let's divide by that. We get r plus r squared is equal to 160 over 8, which is 20. So r squared plus r minus 20 is equal to 0 as required. So that's the answer to part I. So part 2 is to find the value of a. So we're given that r squared plus r minus 20 is equal to 0. So let's first solve for r. So if we factor this, we get r plus 5 times r minus 4 is equal to 0. So we know that r is equal to 4. If r is 4, we also know that a is equal to 8 over r. Therefore, a is equal to 8 over 4, so a is equal to 2. That's our answer for part 2. All right, so let's look at part B. So an arithmetic progression has first term p and common difference 2. The qth term of this progression is 14. And we have a different arithmetic progression that has first term p and common difference 4, and the sum of the first q terms of the progression is 168. So find the values of p and q. All right, so it seems like they've given us two pieces of information. What looks like it might be is the set of simultaneous equations. So let's first rewrite this first part. This first part says first term p common difference 2. It's a qth term, so u of q is equal to 14. If we want to write this in general form, we know that for a series, you have it as the first term, so p plus n minus 1. In this case, it's going to be q minus 1, since this is a qth term, q minus 1 times the difference, which is 2. So we can say that p plus 2 times q minus 1 is equal to 14 is our first equation. Now let's look at the second piece of information. So it says the sum of the first q terms is 168. If we rewrite this the sum formula, it's q over 2 times 2 times the first term, which is q, plus q minus, sorry, the first term is p. Let me just go back to times the first term, p, plus, and then q minus 1, because it's n minus 1 times d, and then d is 4. And then this is equal to 168. We can say, therefore, that q over 2 times, so we know that this here is going to be equal to p plus 2q minus 2 is equal to 14. Over here, on this second equation, we got q over 2 times 2p plus 4q minus 4, when you expand the brackets, is equal to 168. If we, we can see everything in here is divisible by 2, so let's just divide by 2, and we get q times p plus 2q minus 2 is equal to 168. And actually, over here, we don't even need to do more. We can just say that this equation, p plus 2q minus 2 is equal to 14, is also in here. So we can replace this part with 14, since we know it to be true. So 14q is equal to 168. So q must be equal to whatever 168 divided by 14 is, which happens to be 12. So we got the value of q as 12. Now let's find what p is. So we know that p plus 2q minus 1 is equal to 14. If we substitute q in there, we get p plus 2 times 12 minus 1, which is 11, is equal to 14. So p is equal to 14 minus 2 times 11, which is 22. So P is equal to -8. So those are our answers for P and Q. Just identifying that there's a relationship between these two and, not making life so hard for yourself. All right, so question 11. So the diagram shows part of the line y equals 1 and 1 complete period of the curve y equals 1 plus cos x, where x is in radians. The line PQ is a tangent to the curve at P and at Q. The line QR is parallel to the y-axis. Area A is enclosed by the line y equals 1 and the curve. Area B is enclosed by the line y equals 1, the line PQ, and the curve. So we have a ratio of areas. Area A to area B is 1 to k, so we have to find the value of k. All right, so this clearly wants us to find the value of the area A and the value of the area B and then compare it like this. So let's start off by finding the value of area A. So we can see that it's supposed to be bound between y equals 1 and y equals 1 plus cos x. So what we first do is find the points of contact. Where we find the bounds of integration. So if we scroll down, so area A, let's just label that. So first we need to find intersection points. So 1 plus cos x has to equal 1. Therefore, cos x is equal to 0 because you see the y equals 1 is a line. So therefore, y has to equal 1. 1 plus cos x can equal 1 when we're solving this. So if cos x equals 0, remember this is a single period. So there only can be 2 points within this period that work. So x can actually equal pi over 2 or 3 pi over 2 since that's when cos x is 0. So therefore, we can say the area of A is the integral with bounds 3 pi over 2 and pi over 2 of, and then remember that when you're integrating between two curves, it's always the top curve minus the bottom curve. So it would be 1 minus, because y equals 1 is on the top, 1 minus 1 plus cos x dx. So we get the integral of 3 pi over 2 to pi over 2 of, then 1 minus 1 just cancels out, and we've got negative cos x left over because the negative distributes. So we have of negative cos x dx. So let me just drag this over here. We have, if we integrate negative cos x, we get negative sine x. So we have negative sine x with bounds 3 pi over 2 and pi over 2 to substitute. And this is equal to, so we have negative, and the sine 3 pi over 2 is negative 1, so in brackets negative 1. Then we subtract that from the pi over 2 bound. So negative sine pi over 2 is negative 1 because sine pi over 2 is 1. So this is just equal to 2. There's a lot of negative signs. When they all cancel out, equals 2. So area A is equal to 2. Now let's try finding area B. So the way I would find area B looking at this is we could probably just find the area outside B and outside A, and then find it. So we can find the total area of this PQOR rectangle, subtract this outside area from it, and subtract the value of the area of A from it to get the value of B. So let's first find out this outside area. What is the area of this? So what I'm going to do is I'm going to split it up into 2 parts. Since at the middle here, that's when, the curve is 0. So what I'm going to do is I'm going to label this M since it's the middle. I'm going to find the area of this part, which is POM. So I'm going to first write down the statement I just said. A of P, Q, R, O minus, and then POM, you can see is the same as QRM because they're symmetrical. So we can say it's minus 2 times area POM and then minus area A. So we already know what area A is. Let's just focus on finding the areas of these 2 things. So area PQRO, so PQRO is equal to whatever O to R is. So OR must be 2 pi since this is a single period. And then QR, this represents, so we can see Q and P are clearly located at the maximum of this curve. We know cos x's maximum can be 1. Therefore, y equals 2 is probably going to be the maximum it reaches. Therefore, the height is 2. So we can say it's equal to 2 times 2 pi, which is equal to 4 pi. Now, let's try and find the area of POM. So area of POM. So we can see the bounds are going to be from 0 to, and then I'm going to erase this misleading. At M, we have pi. So it's going to be 0 to pi, and it's going to be only at the curve 1 plus cos x, since that's the only curve we're looking at. We're looking at this with the x-axis. That's equal to pi 0 1 plus cos x dx. And when you integrate that, you get x plus sine x with bounds pi and 0. And this just simplifies to pi plus sine 0 minus pi plus sine pi minus 0 minus sine 0. And sine pi minus 0 minus sine 0 is just 0. So this just becomes pi. And if we have already got area A, so we know that area B, therefore, substituting these areas in, we have 4 pi minus 2 pi, because we're multiplying this by 2, remember? So let me just write that, minus 2 pi, and then minus 2, since that's the area of A. And we get 2 pi minus 2. So if we're doing the ratio, area A to area B, and we're told it's 1 to k, we can just use the areas firstly. So we know that area A is 2, that means, and area B is 2 pi minus 2. If we want to make it so that area A is the 1 in this case, we have to divide both sides by 2, because that's how you get from 2 to 1. So we get 1 is half of 2 pi minus 2, since we're halving everything. And that gives you 1 to pi minus 1. So therefore, k is equal to pi minus 1. That's the exact value. Remember to make sure it's exact. So because they have specified, find the exact value of k. All right, let's go down to the next question. Looks like this is the last question of the paper, so let's do it. A curve such that du squared y over dx squared is equal to the following. Given that the gradient of the curve is 4 over 3 to the point 1, comma, minus 1, find the equation of the curve. So this is a classic of many add math questions. They love the integration problems such that you go from a second derivative to the normal curve. So let's first simplify this d squared y over dx squared. So we have d squared y over dx squared, and let's just square this expression, given that it has a square sign here, is equal to root x plus 1 squared over, and then we got the 4th root of x, so that's going to become the root of x instead. And this is equal to x plus 1 plus 2 root x over root x. And let's just break this down. So we can write this as x over root x plus 1 over root x plus 2 root x over root x. That just makes it easier. So we have x over root x plus 1 over root x plus 2 root x over root x. So with this first term, we can see x over root x is actually equal to root x. So we get, I'm going to write this as x to the power of half. That just makes it easier when you're integrating. So you have x to the power of half. Then 1 over root x is the same thing as x to the power of negative half. And then 2 root x over root x is the same as just 2. So that's going to be the expression we have for d squared y over dx squared. Therefore, dy over dx, which is the integral of d squared y over dx squared, must be equal to, so let's just integrate. So raise the power by 1 and then divide by that power to get this for the first term. Same thing for the next term. You should get 2x to the power of half. And then with a constant, you just add the x on, so we get plus 2x. And then we have a constant c that we don't know yet. However, they've given us information that the gradient of the curve is 4 over 3 to the point 1, comma, negative 1. Which means if we substitute the x-coordinate 1 in, we should get 4 over 3. So let's do that. So we get dy over dx. So we have 2 over 3 times 1 to the power of 3 over 2. Remember that anything to the power, 1 to the power of anything is just 1. So I'm just going to write as 2 over 3 just so it's faster. Plus 2, because remember 1 to the power of a half is 1, and multiplying 1 by 2 is still 2. Plus 2, and then plus c is equal to 4 over 3. So we can say that 4 plus c is equal to 2 over 3 when you subtract 2 over 3 from each side. Therefore, c is equal to negative 10 over 3. So what we have here is c is equal to negative 10 over 3. So therefore, dy over dx must be equal to 2 over 3x to the power of 3 over 2 plus 2x to the power of half plus 2x minus 10 over 3. So now let's integrate this one more time to get the original curve. So we get y, when we integrate, is equal to, so 3 over 2 raised at 1 is 5 over 2 divided by 5 over 2 to get multiplied by 2 over 5. We get 4 over 15 x to the power of 5 over 2. You can always check by going back and check it by doing differentiation of what you've just integrated to see if it goes back to the same thing, just to check you're right with your integration. Plus, and then 3 over 2, you flip it around, you get 4 over 3 x to the power of 3 over 2 plus x squared minus 10 over 3x. I'm just going pretty fast with this integration. And then we're going to have another constant. Let's call it d this time. So this time, we have the point 1, comma, negative 1 to go off of. So we can just substitute this in here. So you get negative 1 is equal to 4 over 15. Again, 1 to the power of anything is just 1. And multiply that by the coefficient. It just gives you the coefficient. So I'm going to ignore that 1. Plus 4 over 3 plus 1 minus 10 over 3 plus d. So this becomes, so I'm just going to make everything the common denominator of 15. So first, let's just bring the 1s to the other side. So we get 4 over 15 plus, and then 4 over 3 is the same thing as 20 over 15 minus, and then 10 over 3 is the same thing as 50 over 15. And then you have is equal to negative 3. So we got 24 minus 50, negative 26, plus d. So plus d will be here. Negative 26 over 15 plus d is equal to negative 3. And we know negative 3 is the same thing as negative 45 over 15. So therefore d has to equal negative 19 over 15. So we can check that. Just make sure that you've not done any mistakes. So 4 over 15 plus 4 over 3 minus 10 over 3 negative 6 over 3 negative 6 over 3. Okay, so I made a slight mistake. This is just going to be negative 2 instead. So this should be negative 30 over 15. So this is why it's good to check. So d has to equal negative 4 over 15. Now let's just check one more time. So if we were to collapse these two, that would give us negative 6 over 3, and negative 6 over 3 is negative 2. So we could bring the negative 2 to the other side and give us positive 1, and then subtract this 1 to get, yes, so this should be correct. So we have d is equal to negative 4 over 15. Therefore, the original curve is y is equal to 4 over 15 x to the power of 5 over 2 plus 4 over 3 x to the power of 3 over 2 plus x squared minus 10 over 3 x minus 4 over 15, sorry. And that should be your final answer. Thanks so much for watching this video, and hopefully this past paper walkthrough helped you with your understanding of the AdMath paper. Bye for now.